Okay, so the plunger is pushed in so that the gas is compressed and its volume is reduced at a constant temperature. All right, and we need to explain why decreasing the volume changes the pressure of the gas in the syringe. We must talk about particles in our answer, right? And this is 3 marks, and it's an explain question. Okay, so we need to think about 3 things that we're going to talk about, right? Okay, so if we imagine taking our particles, okay, it's only got 6 particles in. Okay, these are all moving around at random. Okay, my 6 particles. If I push the plunger in, okay, then I've got the same number of particles, but now they're in a smaller volume, right? So what's that going to do? Okay, it's going to mean that they're going to collide with the walls of the container. Okay, and that's an important bit, right? So we've got to talk about collisions, okay, but we must talk about the walls of the container. Okay, you can't just say that, you know, there's more frequent collisions. There are collisions with other particles, that is true, but that doesn't contribute to the pressure, and we'll look at that in a bit more detail in a moment, right? Okay, and then we've got to get this idea that that's happening more times per second, and the easiest way to say that is that it's happening more frequently, right? Okay, so you've still got the same number of collisions with the we've still got the same number of particles in there, but now because they're moving around in a smaller volume, they're colliding with the walls of the container more frequently, right? So what that means is per second, that's going to lead to a larger force, right? Because each time there's a collision, then there's a force. So if it's happening more frequently, that means that there's a larger force on the wall, each second or per unit time, right? Okay, and then the other thing that's happened, of course, is that if you think about like the internal surface area, the bits of this kind of internal cylinder that is hitting, that the surface area of this cylinder is decreased as well. And because pressure is force over area, we've already said that the force has increased. Okay, and if this decreases, if the surface area decreases, then of course that's going to lead to a significant increase in pressure. Okay, now there is one thing that we've got to be very careful with, that all of this is happening at a constant temperature. Okay, so that means that because it's happening at a constant temperature, the average speed of the gas molecules remains the same. All right, so it's not correct to say that the particles are colliding with the walls of the container harder. Okay, because they're not moving any faster. They're still at exactly the same temperature, so the collisions are happening at exactly the same speed. The reason that they're happening more frequently is because now they travel less distance before they bump into another wall, right? So that means that they must be colliding more frequently. So quite a sneaky question in some respects. So, okay, you've got to spot this idea that it's happening at a constant temperature to really get your heads around this. And this question I thought was possibly the hardest one on the entire paper. Why? Not because conceptually it's difficult, but because nearly everybody missed out that word there. All right, this isn't asking for an explanation, it's asking for a description. Okay, so we've got to describe how the average kinetic energy of the gas particles changes when the temperature increases. All right, now that's the challenge here is making sure that you're doing a proper description, okay, rather than an explanation, because lots of you started talking about kinetic theory at this point. Okay, now what we should know, because it's one of the success criteria for the course, Let me just have a look and see if I can find exactly where it is. Okay, here's our checklist. Okay, and it's going to be in P5. Sorry, I should have got this up previously, shouldn't I? Here we go. So there we go. I can explain the relationship between Kelvin temperature and the kinetic energy of the molecules. All right. So we do need to know that relationship. It isn't written in the formula booklet. Okay. But you need to know that the kinetic energy is proportional to big T, which is the Kelvin temperature. Okay. So just writing that down would have got you 2 marks towards this description, that kinetic energy is directly proportional to the Kelvin temperature, which means that if this side of the equation increases, then this side of the equation also increases. So if you double the Kelvin temperature, okay, then that means that you can double the kinetic energy. Okay, quite a challenging one for 3 marks, that.